Hi again everyone! I hope the workshop has been super enjoyable so far and that you've been having lots of fun playing with our clusters and learning about MPI for Pi through our patternlets and exemplar applications. It is probably evident that this workshop was a lot of work for us to put together. Some of you might be wondering, is it at all possible to rapidly integrate PDC into my classroom? One of the reasons why many computing faculty are focused on rapid integration of PDC topics has to do with the new ABET curriculum guidelines for computer science or similarly named programs, which state that CS students should receive exposure to parallel and distributed computing. Considering the level of preparation departments have to undergo for a single ABET visit, it's no small wonder that many faculty are feeling anxious and trying to pick apart this language. Like, what does exposure to parallel and distributed computing really mean? What are the best strategies to employ? Since one of the goals of CSinParallel is to help the CS community integrate PDC topics in the undergraduate curriculum, we are especially interested in hearing from you about your needs, your concerns, and what you feel is missing to aid you in meeting the new ABET requirements. In this session, my colleagues and I are going to focus on specific strategies that we ourselves have used and developed in the classroom. When thinking about how to integrate PDC, there are two documents we encourage you to focus on. The first is the ACM-IEEE Joint Task Force on Computing Curricula's 2013 report, more commonly known as CS 2013, which recommends that CS students be exposed to at least 15 hours of PDC in their undergraduate curriculum. CS 2013 defines several PDC knowledge units and associated learning outcomes. Each learning outcome is classified as either core Tier 1 or Tier 2, or as elective content. CS 2013 recommends that a CS program covers all Tier 1 content, at least 80% of Tier 2 content, and a significant component of elective topics. From our analysis of CS 2013, the Tier 1 and Tier 2 learning outcomes primarily focus on multi-core computing, though there are some learning outcomes related to distributed computing. The other useful document to check out is the NSF-IEEE Curriculum Initiative on Parallel and Distributed Computing, which was released in 2012. They identified over 100 PDC topics and recommended which undergraduate courses were best suited to introduce them. Broadly, TCPP organizes the PDC topics into 4 topic areas: architecture, programming, algorithms, and cross-cutting advanced. Each topic is also given a Bloom's taxonomy classification. It is important to recognize that the TCPP 2012 report predates CS 2013 and that the PDC learning outcomes in CS 2013 are distilled from the TCPP 2012 recommendations. Therefore, it is our recommendation that you primarily use CS 2013 to identify important learning outcomes and then use the TCPP report to figure out which courses to introduce specific outcomes.